Okay, now to measure the gain, you need to set the multimeter to beta or gain. And as you can see, the multimeter is already in gain or HFE mode. Now, by observing the transistor symbol, I can determine the distribution of its pins, collector, base, and emitter. And knowing that this transistor is a PNP type, or rather NPN, sorry. The base is positive. Therefore, the first pin is the collector, the middle one is the base, and the next one is the emitter. Keep in mind that this type of transistor, in this case, has a rounded side, and that rounded side should face backward. And you have to look at the flat part, and by looking at the flat part you will be able to orient yourself with the distribution of the pins. So let's connect it and see what value it gives us. Well, it's 308. In this case, that would be the gain. 308 for this transistor. Now, so we don't forget, let's write down the gain of the BC547 somewhere. Now we're going to test another transistor, which in this case would be from the PNP family. The BC557 is just as small. This transistor has the same pinout as the previous one, but notice that the collector is on this side, then the base and emitter. So this one would fit there. Notice that this one has more gain. It even has 419, so I'll write that down. The BC557 has a gain of 417. Very good. That's how you measure two transistors from the same subfamily, whether they are PNP or NPN. And it's very likely that they will both have some differences in gain. There can be quite a difference or very little. So don't be surprised if you find a transistor with a gain of 200 and then another with 150 or 220. These differences aren't unusual. In fact, it's normal. Sometimes people want all their transistors to have the same gain. That will depend a lot on what the transistor is used for. If it's for amplifying sound waves or signals, then it would be good to categorize them and have transistors with the same gain. In the case of larger transistors, that's a bit more complicated. We'll use these with a breadboard in a moment. Okay, it's connected now. I have the tip 31C transistor, and it's an NPN type. And in this case, it's connected at the top. We have a gain of 162, which is quite different from the 308 of the previous transistor. Let's note that value. Tip 31C would have a profit of 163. Now we move on to the largest one. As you can see, the largest one won't fit on the breadboard. To measure the gain, I'm using alligator clips, and according to the multimeter, we have a gain of 50. As you can see, the more powerful the transistor, or the more current it can handle between the collector and emitter, the lower its gain will be compared to low-power transistors. Therefore, keep this in mind when selecting a transistor.